And we're live. Hello for another session within the Sigma Sprint event, within the Sigma Sprint Builder competition. Today, we are excited to host Alex. And Alex is coming, if I'm not mistaken, from the SUI Foundation, right? Fantastic. So Alice is going to give us a advanced workshop, a deeper dive on SUI, on Move, and all of the things connected to it. So without me kind of going on and on, let's just pass it over to Alex. Alex, go ahead, maybe introduce yourself a little bit and just dive into it.
Yes, hello, thank you very much for the intro. I'm Alex, I'm from the SUI Foundation, the DevRel team. And yeah, today we'll go a bit of a deeper dive in Move and especially how do you use the wormhole part of the Move. I will try to make it so that first I cover that for anyone that's advanced to Move, and after I cover the wormhole part and how do you actually interact with it, and how the main focus will be how do we send and receive messages from wormhole. Then I will go into explaining how actually SwiMove works, so that those that do not want to actually have heard that all before, they can just go and start hacking. So first, allow me to share. A small presentation that will explain exactly what we're doing here. So yeah, sending and receiving wormhole messages. This is the TG group for everyone that hasn't joined. I will stay here for a few seconds, where you can continue and ask questions if something doesn't work, and we will be there to assist you. Okay, going on. Let's explain really briefly what is wormhole. Wormhole is this blue rectangular thing in the middle, and here we have the source chain, and here we have the target chain. So wormhole facilitates messaging between two different chains, blockchains. There is a they also have some guarantees because wormhole has a series of guardians. They're validators that actually sign every message, and then you can check the signature and make sure that the message was never tampered during the transmission. So you have a contract that tells a wormhole core contract to start sending messages, to send a message, and then you have a relayer that will submit this to the target contract, and then you can verify that you can use the wormhole core contract again on the target chain to verify that everything is okay. On today's workshop, the source chain, so we will assume that the source chain is SWI, of course, and actually the source and the target chain, I will deal with the receiving and the sending of the messages mainly. Some lingo. So VIAA stands for verified authenticated. Yeah, I don't remember exactly, but this is what you're going to actually get from the Guardian. So you have a payload that you want to send from one chain to another, and this will be wrapped inside the VAA that you can unwrap it using the wormhole contract. So my idea was to actually do a loyalty point project, a loyalty project where we assume that we have different businesses, marketplaces on different chains, but we want to, and we want to start doing loyalty for our users, but we will use SWI in order to have it as a governance layer. So every time, every time in our chain, in any chain, a user is buying something from that it's relevant to us, then they will gain points, and so we transmit a message to SWI, and every chain can ask SWI, or SWI can just inform every other chain that this user has this many points usable to available for spending. The idea is not very bright because instead of SWI, if you over here had Web2, I think it will go like much easier. So I'm not really but it's very helpful in order to explain both the receive and the send message. So I would not suggest for you to actually go and do this idea. It's just helpful for an example. So yeah, as I said, the focus will be the receive messages and the send messages in Sui, and maybe in the next workshop we will talk about relaying or other stuff that Wormhole can do. The incoming payload, in this case, I wanted to introduce a bit of BCS. BCS is binary canonical serialization. I think it's a native library in Rust, and Sui has a library as well uh, in their standard library that allows you to actually serialize and deserialize using it. I'm thinking that Solana also, because it uses Rust, though I haven't tried it, it would be easy to use it. The most difficult part with the payload usually that I found is how do I serialize the data that it's universally available and understandable by all the contracts, and also not have to do a lot of lead code like question serialization or deserialization every time. This can be a little tricky in your cross-chain application, and I think that you will have to figure out. Sui works really well with BCS, but I'm not sure if Solidity has anything like it, so maybe you will have to be more creative over here. So the points that someone earned, especially on the incoming payload towards Sui, would be like someone spent an amount of value of a token that has some value and bought one of our items, which means that he is eligible to earn some points. The amount of points that they will be earning, it's going to be represented as a U64 as BCS, so it will be a vector of bytes, but it will represent the U64 value for Sui, which means an unsigned integer of 64 bytes. The user address, in our case, I will be using them as a UID. I write here vulnerability. I haven't done exactly the math. I haven't checked it, but if I'm using the user address in every chain, there is a probability that two users have the same address, or two different users have the same address. So I have an address on Sui, someone else has the same address on Solana. That's totally possible. I'm not sure how probable that is, and if it's safe or not to use that as a unique identifier for your users across chains. But in this case, it was just suitable. I had a code for which chain it comes from. In this case, I assume that there's only Sui and another chain. But this is not needed because whenever you get a VAA, you can get the emitter, which means the address that sent it and the chain that it came from with a function that I will show you. And then in my case, I have an operation code because in this case, this payload is to add points, but it can be also to remove points. And the outgoing payload from Sui, it will be just how many points it's which user it is. So the libraries that I'm going to be using. On the Web3 side, I will use the 0x1, which is the standard move library. On Sui, 0x2 is the Sui library, which holds some more all the Sui stuff. And then I will be using the wormhole address on testnet. This is the whole address of it. You don't have to copy it. You can find it at the GitHub from the Wormhole Foundation, the wormhole on the Sui in the Sui folder. There are a few issues over here, and I will show them during coding because the code is a bit outdated. So whenever if you're trying to write the latest code and also be compatible, maybe you will encounter some errors, and I will show you how you can get over them. Also, we are working on this to make sure that the testnet code over here, because we upgrade testnet, it's the code that actually is the best to use, the branch that it's best to use from the wormhole in order to use the Sui on testnet and wormhole on testnet as well. So on the Web2 root libraries, I will use the Foundation SDK and the Admist and Sui in order to create transactions and show you how you actually interact with the chain. Here again, the Wormhole Foundation it's using the SDK is still using the older startmisten.sui.js instead of the admisten.sui. We will work on that and make sure it's up to speed before the hackathon begins. ERL. So all the additional examples. So I'm only doing receiving and sending messages. If you're interested in tokens, there is an example inside the wormhole, like under the Sui folder in examples. There's an example of how you send tokens. The actual code that I have written can be found in this repository over here. I can copy paste it, or I will on the channel, on the TG channel that we have. So yeah, let's go to coding. Actually, I think I will need to stop the presentation and maybe try to share my entire screen. Before I do anything, let me show you what I was talking about with wormhole. So first of all, I assume that anyone that wants to use Sui has the Sui installed, the SCLI, which is really helpful. If you haven't, please go at suidocs.io and search how to get started in order to install it. So with this, I can just write a Sui, move new, and give it a folder, and it will just create a folder, and I have almost everything ready. Lately, a lot of comments have been added, which are quite useless. So allow me to remove them in order to show you exactly what happened, what you may encounter. So in order to use the wormhole library, you should add over here wormhole. There's another better way to write this, and let me make it a bit bigger. I hope it's better now. And I can make it even better. So yeah, dependencies, that's way you give a git. This will be there already, but you can copy it in the way that I wrote it. And you need to add the dependencies, that wormhole. And the revision here will be the actual branch. As I said, it's Sui upgrade testnet in order to work everything with, for everything to work with testnet. Now over here, usually for Sui by default, it will be something like framework testnet, which is the indicated. But if you try to do that, so if we try to build, we will get a big error that says failed to build modules when resolving dependencies for package contracts, conflicted version of move standard lib. So Sui, as I said, evolves really fast, and in the standard library has changed. There's no, all the changes are backwards compatible, but still the way that the client is made is it checks the actual binaries one-to-one, and if they should match. And in this case, they will not match, and you may get this error. The easiest way to overcome it is to just use the same revision as wormhole does, and the way you can find that is you just go to the wormhole foundation to the wormhole git, you choose SWI upgrade testnet over here as a branch. Uh, you go to SWI and wormhole. By the way, the examples that I was talking about are here, but now we're going to the main code. So here they have a move testnet tunnel, and then here you will see the revision that they're using. So if you just copy paste that and put it over here, then if you go ahead and try and build this time, it should work. This comes though with the downside that a few of the new receiver syntax are not yet available in this revision. So everything in, as you saw in move standard library, everything that has to do with the receiver syntax of vectors or the macros, stuff like that, will not work with this revision. So you will have to write the old move. Having said that, before I start writing any code, I want to go through the code that already exists, and I want to go through the messages, which is how you send a message. Actually, whenever you whenever you build, you download all the sources, so you don't have to. You can find in the sources dependencies the wormhole. As I said, so all of this code over here, all the sources inside the wormhole SWI wormhole, you will be finding them. You will see that they got downloaded. So instead of checking them online as you code, you can check them here on the fly. As I said, we are going to be using. Sorry, allow me to close it. Telegram. As I said, we'll be using the VAA a lot. And you can check the module itself and check the comments. They are really helpful. So this module implements a mechanism to parse and verify VAAs, which are verified wormhole messages. Messages with Guardian signature attesting to its observation. And here you can see the whole code, what we actually look. So in the code I'm using take payload. I think that in the production code you will get the take emitter info and payload, which also gives you the emitter chain, and that's why I said that I in the payload I also have the chain, but it's just not needed because you get it over here. The emitter address and the payload itself. So if you have a VAA, you can get the actual thing that you care, and you can do your checks with the chain and the address. In order to get that, you need a parse and verify. So what you will actually get, it will be a vector of many bytes, so vector of U8, U8 being the unsigned integer up to 255. So you will get a very big vector, and you will have to pass it along with the state and the clock, and I will show you where you get them. And this parse and verify, as you see here in the definition, it returns the VAA. So after you get the VAA, you call the take emitter and info payload with the VAA, which destroys, as we see over here, the VAA, and you get the info that you actually need. Then you get the payload, and then you will have to deal with it, deserialize it, and use it. And there is one more thing that we care about. So there's also the publish message.move, which of course publishes the message. Make really sure to check here the code, the comments, to see how exactly it was intended to work. I will explain it as well. But it says publish message emits a message as a SWI event. This info uses the emitter cap. We will see how we create an emitter cap. As the register sender. It is important for integrators. This is the important part. It is important for integrators to refrain from calling this method within their contract. This method is meant to be called in a transaction block, in a programmable transaction block, after receiving a message ticket from calling prepare message. So this is the method that we actually want, the prepare message. This, as we see, will return a message ticket which is needed inside the publish message over here. So they need a message ticket, a coin. This should always be an empty coin if you're doing testnet, because the fees are 0. The state, which already exists in testnet, this is a unique object and it has an ID that we can find. And the clock, which ID is 00x6. So you actually need a message ticket. In a PTB, you first call prepare message, you take the result and you put it inside the publish message. So these are the main functions that we will use. So for receive message, I'm expecting to be given the raw vector, the raw VAA, which is the buffer, as we saw, a vector of U8, the message that it's coming from wormhole. I will need the wormhole state and the clock in order to be able to call the parse and verify. So whenever we have the vector, we just call parse and verify with all the necessary arguments, and we get the VAA. Then we extract the payload. Here I'm using take payload, but it's more suggested, more indicated that you use the take emitter info and payload in order to actually do checks. I'm not doing any checks. The only thing that I'm doing, I'm parsing it. As I said, that I'm expecting to be getting an operation code. For me, if it's 0, I add points to the user that I'm getting. If it's 1, I'm removing points. The chain, which the take emitter info will return it anyways. That's why I'm not even using it over here. The user, in our case, in my case, it's a vector U8, which is the public key of the user, the actual bytes of the address. The public key for Solana address, and for Sui address, it will be just the address, the bytes that the address wraps around. And the amount of points as a U64, which is the amount of points to either add or remove. So here I have both the suggested and the non-suggested way on how you create a new message. In my case, the messages will contain the user address itself as bytes and the amount of points. And in my code over here, the amounts of points are hidden inside a shared object that I'm creating in another module. So I get the points. So it's inside the table data points. For every user, I'm keeping their points. And I create the prepare payload, which returns a vector of bytes. And then I publish, I use the wormhole publish message prepare message to return a message ticket over here. And we're supposed to use in a PTB and then call the publish message from wormhole. Of course, this can happen on the move side. The reason why you're supposed to do it in a PTB is because after an upgrade, this code will not work anymore if a contract upgrade happens. And if I'm going to change the code, maybe it may happen like really soon. So if a contract update happens, then if you call publish message over here with a wormhole state that it's not correct, no. Actually, you're giving them a wormhole state, but still there is an issue of versions that it will stop working, and then this call after the version goes up, this function will always fail. Of course, you're in testnet and you can just republish with a new version. So for the hackathon, I guess you could do it, but it's suggested that you do it as the wormhole team intended. to gain more points. So message ticket, I call a new message here, but I could just call the prepare message itself, and then I call directly the publish message, and this will send a message to, it will go to Wormhole. And we will see that in action as well. So I will take a break. I said a lot of things over here. I will take a break for any questions right now. If there are. And then I will continue with the actual. Okay, there are no questions. That's very good. So this is how you use the move code that interacts with Wormhole. Now we will go over the full example, and then I will show you the PTBs as well. For those that are already familiar with all of this, you can go on and skip the next section. So let me share again. Let me see what I'm doing wrong over here. Oh yeah, I fixed the type. So I have over here, I have a, let's talk about move first. Yeah, let's go to our new contract. Let's talk about the very basics of moves. So in Sui, you have a package which usually is indicated by a big a folder that contains usually a sources. That doesn't matter though. It contains a lot of move files which are called modules. Some of them may be test modules, and the test modules are indicated by a test only above them, and the others start again as module, and then you have to copy to write the package name, which is the, yeah, and then the module name. And in this case I will change the module name to make it more clear. So I named it intro. We also, so contracts intro. When this gets published on chain, the contracts will disappear and will get a full address. The intro will always remain. If you want to access on chain, like if you want to call on chain any function inside here that we might write, like public function hi. If you want to call this, you will need to get, after we publish, we get over here a big address like 0x 0x and a lot of numbers, and actually a lot of hex characters. So yeah, 5, it's okay. And then intro colon intro, and then colon hi. So this would be the way that this would be the full path or the full address of any item inside the module. So whether it's a function, whether it's a struct. So there are two, and both the structs are only public for now. They will be private in the future. So a struct would look something like this. It may or may not have some abilities that we're going to talk about. And then it will have some fields. So if you want this struct, let's name it person again. After you have published it on chain, you will get the same, it will be always the same, and that's why I will copy paste it, big address. and then again, in this case, it's intro, the module, and then the person. And that would be the actual type of this track. And every time we create such an object, everything that has an ID on Sui is an object. You will see that it has this type. Uh, so now getting started. On Sui, here we still need to import the string. That's why I'm getting a red line. The string is in the standard library. String. As you see, is the same pattern over here. This can be either standard library or 0x1. This is the actual address of the standard library on chain. And inside the string module, you can find the string definition. String is not exactly a primitive. The primitives in Sui are primitive one can be its address. Another primitive can be a boolean denoted by bool. And then you have all the unsigned integers, which range from U8 up to U256. So it's U8, U16, U32, U64, U128, and U256. The reason why we have so many unsigned integers is because a U64 contains like 8 bytes, a U8 contains only 1 byte. So 8 bytes will always be allocated whenever you create. So if this field is a U64, this is 8 bytes. So every time I create a person, and we'll see how every time I create a person, this amount of space will be allocated. So on blockchain, it's good to be frugal with space. If I don't need up to max U64 numbers, then if I'm okay with having up to 256 and it's a reasonable range, then it's suggested that you use a smaller unsigned integer. There are no signed integers on Sui and no floats, as in most blockchains. So the restring that we saw, and there are vectors, of course. So a vector of a primitive is also considered a primitive, and a vector of non-primitives is considered a non-primitive. And I will explain the difference when we go through the abilities over here. Of course, if you want to check them, whenever you build, whenever you build successfully, you will get both the standard library and the Sui. In the standard library, the most useful things are the option, the string. So over here, you can find the definition of a string, and as you will see, it's a struct that only holds bytes of a vector of U8. So it only holds a vector of bytes. And for vector, the same. Vector has a lot of native functions, but you can see all the functions that you can actually use, like singleton, reverse, append is empty, contains. You should have push back and pop back, so on and so on. So this would be the main primitive structures. Any other data structures you want to create, it will be a struct that you define. So I can create a struct called map, for example. And let's talk about abilities. So there are 4 abilities over here in Sui: copy and drop. Key means that after this struct is instantiated, like another instance is created, it will become an item inside the global storage. So it should always have an ID. So the first field over here should always be ID of type UID. The type UID can be found in Sui objects. So Even though it's not required, allow me to import it. So it's in the SWI library, not in the standard library. Object UID. And this will always be unique. So everything that has key becomes automatically what we call in Move an object. The store allows you, so key and store go together, but the store would allow me to do this that I'm going to do right now. So the store ability would allow me to have to put this type of structs inside inside another object. So inside another struct. So if I want this struct to be wrapped around another struct, I need to put this store ability. If I delete it, most probably, yeah, this turns red, invalid type field, because it does not have store. The copy ability means I can make copies. The drop ability means I can forget it at the end of the block. So as I write a function, two brackets are considered a block. If I say that this is a map which has a field 1 of 87, 85, as long as it has the drop ability, what I'm doing right now will not, even though it gives me a warning, it won't give me an error. If it doesn't have the drop ability over here, this will immediately turn red, and it will tell me that the map does not have the drop ability, so I cannot just write down the variable and then forget it and expect it to disappear at the end of the block. It will not be garbage collected. You will always get an error, so you will have to either destructure it yourself, either, well, by destructuring means that you just do this. It looks like JavaScript. And then I get back the field 1. So over here, I took the map and I just took the fields inside. So the map, this struct stops to exist after you write the code, the destructuring code. So either I'm destructuring it, either if it has store, maybe I wrap it inside another object. If it has key, then I can send it to addresses. I have to do something if drop is missing. But copy allows me to do this, map1 equals map, and this will create a new map. SWI is very heavily influenced by Rust, so you have the reference. So map right now, as soon as we defined it, it will hold some, it will be allocated, there will be in the heap or in the stack, and then you can have a reference, a pointer to their location in memory. You can have a mutable reference to their location in memory, which would allow you to actually mutate it, but you have to declare it over here first that I want this variable to be mutated. So yeah, you can have a mutable reference, or you can get it by value. So if an ability has copy, it will create another, it will in the memory, it will allocate another the amount of necessary bytes, and will create the same thing twice, so you'll get a copy of it. If the copy is missing though, then map1 and map2 point to the same place in memory. And you see, so over here I already used map is not existent because right now it's map1, so I just changed the name. And when I add the copy, this is allowed, but because it does not have drop, I have to actually destructure or do something with map1 as well. Now, in your code, you will usually want to create stuff that appears on chain and under addresses. So in most cases, there will be key and store. If something has key and store, then except of that thing being wrappable inside other objects, other objects that also have store. Another thing that you are allowed to do is that you can transfer them. So you can everything that has key and store can be transferred. It's transferable. Everything that has only key, it's all bound, and you can define inside this module the way if and how you want it to be transferred. One of the most important security features of Move is that whenever you define a struct, and this is what the Move module is all about, is defining your structs and then defining the functions that will eventually be transactions on chain that allow you to mutate. You can write an add wait function since I wrote wait, and you can request a person over here, an instance of person. I will just take a mutable because I don't need it by value. And the amount of weight that you want to add, this should be a U64. So I can do person that weight equals the previous weight. I have to write it again, plus the new amount, the new weight. So I'm allowed to do this over here. I will not be allowed in any other module. So in any other module, even if I import the person, I will not be allowed to do person that weight. I will not be allowed to change it. If I want to be able to change any field over here from any way for any reason, any logic reason, I mean business logic reason, then you need to write the functions that define that way. So the only way for any other module to change the weight is just to call this add weight because I made it a public function. A function can be public, it can be private without the public. That means it can also be an entry, which means that this can be only called from it can only be called from the Web2. It cannot be called from another module. That is a very rare case, though. We don't usually use it, so usually most are either public that we want them to be callable, or just private that is there internal to the module itself. So for any other module, if they want to actually mutate person to change, they can only mutate the weight right now because they can only increase it because this is the logic that I wrote over here. So every module is like that. You write your structs and then you write the functions that allows you to mutate different fields that according to business logic. And of course, if you want to read them as well, like get weight, you have to write it over here. This kind of syntax will not be allowed, I repeat, in any other module. So again, I have to give a person here. I don't need sorry, it's a function. I don't even need a mutable reference. I can take just a simple reference and do person that weight. And this of course, I'm returning a weight. I have to say that I'm returning a U64 over here. One way to write this is just return, but return is not needed. Every line should have a semicolon at the end except the return line. So if something lacks the return line, the semicolon will be returned. And now I had to do person, so yeah. This will be a bit macabre. I want to kill a person. In this case, I cannot use a reference. I have to take it by value. So in order to destructure to destructure, destroy an instance, I said I wrote it before, but here you just write all, and in this case I have a lot. So right now I have an ID over here. The ID again is not some. It does not have drop, so it will tell me over here the local variable ID still contains a value, meaning that it does not have drop. All the other, the string, the U64, the addresses, all the primitives, and the vector of primitives have drop. So I can just write that I'm not going to care about them. This is the way to do that. But in order to delete an object, you will need to eventually call wait, object delete and give the ID that it was given. And in order to create one, or usually it's mint, then besides the ID, usually you would have to give everything else from the web tool. I will ask only for these two things here, and this will return a person. And in order to create an ID, I did an object new and the transaction context. So an optional variable at the end of every function should be the transaction context. When you're calling it from the Web2 side, this will be given by the runtime. It's not something that you input. But this holds all the IDs and it holds the sender of the transaction, the caller or the signer. So whenever we create a new ID, we need the context. Whenever we do anything else, whenever you delete, we don't need it, so we don't have to write. So yeah, in here I need the ID, I need the name, I need the weight, and all the other. I need an address. An address is written like this. It should be 64 characters long. If you input an address less than 64 characters long, they automatically there will be zeros added until it becomes 64 characters long. A boolean is either true or false. U8 it should be just less than 255. A vector of U8 can be declared like this. And a vector of U64s again. If you want to denote that this number is a U8, you can just add the U8 at the beginning, at the end. And if I want to denote that this number is a U64, I just add the U64. And this should be okay, but why it's not? Oh yeah. I need to actually add the name of each. I have a type. And this is too big. There's no U8 325. So, and now you have to return the person because we said that we're going to return it. Okay, this would be the quick intro to Move. Let me check if there are any questions in the chat. How do we restrict the users that can run a function, e.g. a mint if called by a minter? I will show that in the code. There are two ways of doing that. If in this case I'm getting the context in the mean, so and I'll show you how do you write assertions. You can either have a constant that says admin or something. In this case, it's an address. This is the more naive way, and I will show you the indicated way as well. So yeah, this would be the admin, and you can do an assertion over here, and this is really helpful. So I can show you the assertions themselves. Assertions. So it has two arguments over here. One argument would be a U64, which will be in error code, and the other argument should return a Boolean, and it's something that you would like to happen. So in this case, what I'm trying to what I'm asked to do is that I must make sure that the sender of this transaction is always the admin, for example. So if this turns out true, then everything is okay. If this turns out false, then I will get an error when running the transaction, and they will say error code 0. And we have a convention. Usually at Move, we assign these errors to constant. So I say error, not admin over here. This should always be U64. And instead of writing 0, I write here not admin. So in the contract again, on the Web2 side again, I will see a 0, but then when I open the code, I can see what 0 points to. I can go just up here and see what the 0 points to, and I would say, oh, not admin, so I don't have to go and check the actual line where it failed to understand what happened. And this is a reason why we do it like that. It's not really necessary though. And the other way is the more sophisticated way, is you do a struct, an object. Usually we name them admin cap, has key and star maybe, and only an ID, nothing else. And you create only one of them. The way that you create only one of them is by calling a special function that's called init. This function will be called only once in the whole lifetime when you publish it. So when you publish this code onto testnet, this init function will be called, but it will not be called again ever. Like, not, you can upgrade contracts, but the init will not be called. So in the init, I can create a capability, this admin cap. I can say, yeah, the ID is going to be a new ID. And then I can transfer it to whoever publishes, for example. So I can transfer the cap to whoever published the contract. And so this piece of code, make sure that there is only one admin cap. I haven't written here, but I could write functions that create or delete or destroy admin caps. Right now, as far as this code goes, there will be one admin cap created, and then it will be transferred to the publisher of the contract, and that's all there is to it. So, and then I would come over here at the mean person, and I will say, I want you to show me that you have an admin cap. So this is an underscore, so underscore cap means I'm not going to use this reference, this argument, but I want it to be provided. So after you publish, you will get only one admin cap. This will be an owned object under your address. It will have their own ID. So when you call it from the Web2, you will have to give as the first argument to the transaction the ID of the admin cap. And you also have to own it. So if the sender is not the owner of the admin cap, then the transaction will fail from the VM. And that's the usual way to do it. In the code though, I used this approach. But with a twist. So now I can share this code. Yeah, I can share it on TG. There's no, I mean, I can push it. Yeah, wait a moment. Let me change my branches. Intro branch. I will name it intro branch. I won't have it in main. Actually, let me check that it actually builds before I give you code that doesn't. It should build. It has, yeah. It has some warnings that I'm not using all the variables, but oh, sorry, it does not have any errors. So that's good enough. Okay. Introductory code. So we're done with that. And now let's briefly go over the code that you will see, the rest of the code that you will see. Uh, in the contracts. Sources. So in the loyalty, I create, this will be a shared object. So in Sui, you have shared and owned objects. Owned objects are inside addresses. Shared objects are in the global storage. Everyone can access them and input them as arguments to a transaction. But shared objects can only be, owned objects can only be inputted as arguments to a transaction by the actual address owner. So I have a shared object that I have the admin address over here, as I said. I have a UID, and I have the points, the actual loyalty points of the users. I'm using a table, which is the map, and the table, the keys are the vector of an array of bytes, which is actually the address, the public key of the user, depending on the chain, because I decided to use that as an unique identifier, and then the U64 would be the points of every user. So I have an init function that creates only one loyalty data, and then it shares it. This is how we share an object and move. I have a function though that allows me to change an admin, so even if my address gets if my private key gets compromised, at least I can change it to a non-compromised and maybe save the day. I have a public package over here, means that this function cannot be called, it can only be called from another module inside the same package. So here I have only the basic logic on how I want to manipulate loyalty data. So I want to be able to add points to users, and I want to be able to remove points. And then I need some getter. The getter is only like how many points a user have. In this case, it may be a bit overkill to just have them separated, but I just separated this code in order, like, if the code base would be bigger, it would make a lot much more sense to have like different modules doing their own stuff. Like, it's like separation of concerns. So add points if the loyalty points are more than 0. So yeah, maybe sometimes I'll be called with 0. I don't want to do anything of this, any action. But if the loyalty beyonds that I'm given are more than 0, if the user exists, then I will change. And this is the code on how you may change on a table the value. Otherwise, I add to the table a new user with the loyalty points that they got. This is how we remove points, the same idea, but in here I assert that the users indeed exist. If the message is wrong, then it will just fail. And then there's the messages and how we send the messages. We went over this. And lastly is the Web3, the Web2 part. Here I have a util which creates a signer, so you will need an environment that I'm not going to open, and you will need a private key. So just make sure like priv key new or something. Actually, sui address new. Let me check. Sui client. Uh, if you check the Sui client, you can create a new private key by doing new address. So yeah, it will generate a new address with a key pair, and you can get the key pair from. Let me show you the file. So if you will do the as soon as you install the Swiss client, you will get a Sui folder inside your home directory, and then in Sui config Sui key store you will find all your private keys. I will not cut that. I will not press enter over here. You can check them. You will get B64, and in order to actually get the private key as I have it, you would need to do Sui key tool convert, and you give the B64 string over here, and we'll just transform in all possible all possible formats. You will use the one that says Sui priv key. It starts with Sui priv key in order for this code to work. So I get the signer. I have some scripts over here because I did not write any code on any other chain. So if I emit a Solana message, but I emit it with the SDK, and I'm sending the payload. Is very very specific over here. It's hard coded. It didn't have to be, but it's just an example. And I'm sending over here the VAA, and I'm writing it also to a file just in case, because I need it for the tests. And then oh yeah, so I'm getting the VAA over here. I'm not using any relayers. The VAA, I'm getting the VAA directly from Wormhole, and then with the return of this function over here, I will just put it inside the update Sui contract in order to, and I'm calling the receive message that I wrote. And all of this happens down here. Like I have a receive message. First I'm doing an emit Solana message, and then if I got anything, I just call the update Sui contract, and this will change the contract. The loyalty data will be increased for the user. The users and all of that are inside here, so I have some constants, this package ID. So let me actually do this over here. So this 4 will change for you. You will use your own Solana public key. You will have to create an emitter cap, which I have over here the code on how you create an emitter cap. So yeah, it's get emitter cap over here. So it will just, you can create as many as you want, but only one it's enough. And after you got it, you check the response and you put the address of the item over here, the ID of the item. And this will be the package that after you do a Sui client publish. Yeah, you might get this error. So you do a Sui client publish skip dependency verification. Yeah, you will get a package ID. So this package ID, you will have to insert it over here. You will, depending on, you will see some created objects. In this case, this is an admin cap, but for the other contract, this is the contract of the intro. For the other contract, you will see a shared object. You will get that ID as well from the publish. response. And then yeah, try the scripts. They are working. Any questions? I'm over time. I wanted to go over this as well, but I took too long explaining the basics. Sorry for that. Try to tell me if you get an error. Let me push the latest version. Uh, so Constance messages. Yeah, okay. Sorry. I will fix it soon. Let me stop their sharing, and I will push them just in a minute. Thank you very much for your patience.
All right, this was awesome, actually. Let me get back on the main stage. So the only thing that, let's see, the only thing that I would ask you is maybe you can send me over the code base, and I can share this
Yeah.
with folks.
Let me send it over here. Let
Perfect.
me send in the chat. Let me send it on Telegram. I Telegram because it keeps beeping, but I can open it right now.
Awesome. Thank you very much. Right. I think if there's no questions, I think we can wrap this up. People can always reach you async as well.
Yeah, you
You
can
can.
always reach on Sync if you want actually to have a version 2 of a continuation of this workshop and show you the Web 2 side and it feels too complicated. Just talk with the Wormhole Foundation and they can find me and we can make that happen, I guess.
Sweet. Awesome. Thank you very much. This was fantastic, actually. Really, really good deep dive. Thank you very much, everybody, for listening, participating, asking questions, being around. I will actually hop over into. Oh, we need version 2. Like, I'm
Make
gonna
that
hop
happen.
over into the. Yeah, I'm gonna hop over into the office hours. If anybody wants to join, feel free. I think you should have the link in your calendar invites. Otherwise, yeah. Alex, again, thank you very much. This was a great session. Thank you, everybody, for participating. I'll see you on the next one. Thank you. Bye.